In this video, we are going to learn how to calculate work done by a force. We define work as a product of force times displacement. And if this force is not in the direction of displacement, we take the component of force that is in the direction of d and calculate the work as F d cosine theta, where theta is the angle between the force and the displacement. You can also calculate work by taking the dot product of F and the displacement R. So in this video, we are going to use each of these equations to calculate the work done by a force. Let's look at question 5.26. A force of 5 Newton acts over a distance of 12 meter in the direction of the force. Find the work done. So this question has given me the magnitude of force, which is 5 Newton, and the displacement, the distance it covers, 12 meter. My force and distance are in this direction. So we can calculate the work by taking the product of force and displacement, 5 times 12, and that will give you the work done as 60 joule. So this is a very simple problem where work can be calculating by just multiplying force and distance. And this rule you can use directly whenever force and displacement are in the same direction. Question 5.30. You push your couch a distance of 4 meters across the living room floor with a horizontal force of 200 Newton. Force of friction is 150 Newton. What is the work done by you, by the friction force, by gravity, and by the net force? So let's sketch the problem. Question says you have a couch and you push the couch with a force of 200 Newton. So the force that you applied, I will FA. And this FA is 200 Newton. When you move the couch with this horizontal force, it moves the distance of 4 meters. Force of friction always acts opposite to motion. So the force of friction acting on the couch is in direction opposite to its motion. I will call this FF, and it is given by 150 Newton. And the force due to gravity acting on the object is always acting vertically down. This is Fg. I need to find what is work done by you, work done by the force of friction, by gravity, and by the net force. Now, since my applied force is in the same direction as the distance, theta over here we will take as 0. Whenever you have force and displacement in the same direction, theta comes out to be 0. Force of friction acts opposite to the displacement, acts opposite to the motion. So my angle theta here will be 180. So when two vectors are opposite to each other, if they are pointing opposite to each other, the angle between them is 180. Gravity acts perpendicular to the direction of motion because gravity is acting vertically downward and my displacement is along the right here in the figure. So I will write theta for force due to gravity is 90. I need to find work done by each of these forces. Let's start with work done by you. I will write applied force F d cosine theta. The reason I'm using theta in this equation is because here there are different forces involved and not all of them are acting in the same direction as your displacement. So force applied by you is 200 times 4 into cosine 0. That will give you 800 Joule. This is work done by you. Then we find the work done by the friction force. So we write for friction here, work done by friction. Again the same rule, Ft cosine theta. Force of friction is 150. The distance covered will be the same for all the work. For all the forces, the distance covered will be 4 meter. 4. Theta over here is 180. And when you calculate this, you get work done by the force of friction is negative 600 Joule. Then we have work done by gravity. Fgt cosine theta. So I write Fgt cosine 90. I know cosine 90 is 0. So I do not need to calculate what is Fg to find this work done. Whenever force and displacement are perpendicular to each other, work done in this situation will come out to be 0. So work done by gravity will be 0. Then they want me to find what is work done by the net force. So there are two ways of finding that. I calculated what is work done by each of the forces. So we can just calculate the net force by adding work done by each force. So work done by U plus work done by the force of friction plus work done by gravity. So we add the value 800 minus 600 plus 0. That will give me 200 Joule. So this is how you calculate the net work if you already know work done by each of the forces. If not, then you can find the net work by taking product of the net force times displacement. And when you are taking this net force, you need to take into consideration the direction of these forces. So you can do it in this manner. You can individually add this value. So I can find my F applied d cosine 0 plus F of friction d cosine 180 plus F of g d cosine 90. You can do it in this manner, or you can write the net force by taking into consideration that applied force acts in the same direction as displacement, so we take it positive. Force of friction acts opposite to the displacement, so we take it negative. I will not include force due to gravity here because force due to gravity and displacement are perpendicular to each other, so work done by that force will be 0. And we take only the forces along the x-axis for the moment. So you calculate the net force and multiply with d. So when I put the rule for net force here, when I put the value, I get 200 minus 150 into d, which is 4, and that will still give you 200 Joule. So you can use any method. You can calculate work done by individual forces and add them, or you can use the rule for net force to find the work done. And when you're using the rule for net force, solve x-axis and y-axis separately. And generally forces along the axis which is perpendicular to the displacement, work done for those forces will be 0. Like for gravity, work done by gravity here is 0 since the couch is not moving along the y-axis. Question 5.33. Here you have a constant force F given by its coordinates value, acts on an object which has a mass of 18 kilogram, causing a displacement of that object by R. This is the displacement. What is the total work done by this force? So first let us write down the value of my force and displacement. So first here F is given in terms of its coordinates. The x coordinate, y coordinate, and the z coordinates. It's written in vector format in terms of its coordinates, as well as the value of R. 4.25, 3.69, and negative 2.45. Now, whenever force and displacement are written in terms of their vector coordinates or in vector formats, where they give you value of F as, let's say, this is just an example, x cap plus 2y cap plus 8z cap. So whenever they give you force and displacement in vector coordinates, we use the dot product of force and displacement to find the work. So here we are going to use the third rule we discussed before. Work done will be dot product of force times displacement. F dot R. So how do you calculate the dot product? To find the dot product of force and displacement, you multiply the x values together, Fx times Rx, plus product of y values, Fy times Ry, plus product of the z values, Fz dot Rz. So here in my given quantities, the first term here is my x coordinate, second is y, third is z. Same with R. First term is my x coordinate, second y, and then third is z. So we substitute here. Fx is 4.79, Rx is 4.25, plus Fy is negative 3.79, Ry is 3.69, plus Fz is 2.09, and Rz is negative 2.45. And when you add them all, when you solve them, you get the value of work as 1.25 joule. So whenever question gives you force and displacement in vector format or in the form of their coordinates, in terms of their coordinates, you always have to use the dot product of force and displacement to find the work. So dot product will become product of x plus product of y values plus product of z values.